Today we are going to discuss data representation part 2. So last class we were discussed about introduction about data representation, various digital number system like binary, octal, decimal and hexadecimal, and we were discussed about number conversions like how to convert decimal numbers to other number systems and how to convert binary to other number systems. Today we are going to discuss about number conversions like octal to other number methods and hexadecimal to other number methods. And next topic we are going to discuss about how to represent unsigned integers in binary. At last we are going to discuss about binary addition. Octal to other number system conversion. So in that we are going to discuss about octal to binary, octal to decimal and octal to hexadecimal. Let us start with octal to binary. How to convert octal to binary? We have to take each octal digit and to represent its 3-digit binary format. At last we have to combine all the binary representation to form a single binary number. So here you can see the table, right? So each and every octal digit will be represented in the binary format with the help of 421. For example, 723 with the base 8. What is base 8? It is a octal number which has the symbol 0 to 7. So here we have to take each octal digit like 7 and 2 and 3 and we have to represent it in the form of binary format. You can refer this table to make a binary numbers. At last we have to combine all the binary equivalent from the most significant bit. So which one is most significant bit? Here 7 is the most significant bit. We have to start writing the binary equivalent from 111 0 1 0 0 1 1. This is going to be an answer for octal to binary. Octal fraction to binary. How to convert octal fraction to binary? So similarly what we have discussed in the last slide. Okay, so first we have to take each octal digit and we have to substitute with the respective binary value. For example, here we have 3, right? We have to substitute 0 1 1 in place of 3 and 5. We have to substitute 101 in place of 2. We have to substitute 0 1 0. At last we have to combine all the values starting from your most significant bit. Which one is most significant bit here? 3 is your most significant bit in your left hand side. So you have to start write your answer from 0 1 1 101 010 dot 101 110 and 0 1 1. Next one we are going to discuss about octal to decimal. How to convert octal to decimal? To convert octal number to decimal, multiply each octal digit by its positional weight. For example, 5 to 3. So here the 5 will be multiplied with the positional weight of 8 to the power 2 and 2 is multiplied with the positional weight of 8 to the power 1 and 3 is multiplied with the positional weight of 8 to the power 0. At sum of all the terms which is going to give the decimal value. And next method is repetitive division method. In case of repetitive division method, initially we need to consider decimal result as 0 and the octal digit, the most significant bit, right? The leftmost bit, we have to remove it and that value will be added with the decimal results. So which will give you the decimal result as 3. That 3 is multiplied with your operation called 8. Why we are taking 8? So 8 is the base of octal number. So we are multiplying this decimal result with the 8 which will give you the result as 24. The second step, what are the digits we left in that number? 4 5. So I am going to remove this 4. This 4 will be added with my decimal result. So here at last we have 24 my decimal result. I am going to add this 4 which will give it 28. This 28 will be multiplied with the 8 and which will give you 224. So the remaining bit in my number is 5. So this 5 will be added up with me decimal result which will give you 224. At last we don't have any other number, so we'll stop this operation and the result of this process is 229. So next one, octal fraction to decimal. So octal fraction to decimal is similar way what we have did for octal to decimal. So each octal number will be multiplied with its positional value. So here the 7 is multiplied with the positional value 8 to the power 2, and 2 is multiplied with the positional value 8 to the power 1, and 5 is multiplied with its positional value 8 to the power 0, and 3 is multiplied with the positional value 8 to the power minus 1, and 6 is multiplied with the positional value 8 to the power minus 2. Adding all the terms which will give you the decimal number. Next one, octal to hexadecimal. So octal to hexadecimal, the first step we have to convert octal number to a binary number. How to convert octal number to binary? So we need to represent each octal digit by a 3-digit binary number. From the complete binary number, we can group it 4 binary digit around the decimal point. So at last, convert each 4-digit binary group to an equivalent hexadecimal digit. For example, 752 with the base 8. So I am going to convert this 752 into hexadecimal. So first step, what we need to do, so each octal digit like 7 will be substituted with the binary equivalent 111, and 5 is substituted with 101, and 2 is substituted with 010. So we will get one binary equivalent number. In step 2, we need to convert this binary to the hexadecimal conversion. So how to convert binary to hexadecimal? So split the number by 4 groups. So we will get the decimal, that is hexadecimal number. How to convert octal fraction to hexadecimal? For example, here I have the number 26.2. First I am going to take the each octal digit, right? So here the octal digit 2, 6 and 2 will be substituted with the respective binary 3-digit number. From the 3-digit number I am going to group them into 4-digit in order to make it as hexadecimal number. Suppose in your MSB if you are getting only 2-digit, so in order to make the hexadecimal number, we can add extra zeros in front of your MSB. And similar way in LSB you have only 3-digit. In order to make the 4-digit, you need to add that extra zeros in the LSB so that you will get 4-digit number. After that you can group the numbers, will get the corresponding hexadecimal value. So similar way, the next one, conversion from hexadecimal to other number systems. So in hexadecimal to other number system, we are going to discuss about hexadecimal to binary, hexadecimal to octal and hexadecimal to decimal. How to convert hexadecimal to binary? So here we need to take each hexadecimal digit should be converted with its 4-bit binary equivalent. For example, here we have the number 9E4. So each hexadecimal digit should be represented with 4-bit binary equivalent. Like 9 will be represented as 1001, and E is nothing but hexadecimal digit number 14. So it should be represented with 1110, and 4 going to represent as 0100. At last we need to combine all the binary equivalent from the most significant bit. Next, hexadecimal fraction to binary, it's similar way what we have discussed in the last slide. So here also we need to take each hexadecimal digit should be converted with 4-bit binary equivalent. At last we need to combine all the results from the most significant bit. Which one is most significant bit here? Yes, it is 3. Hexadecimal to octal. Here we have 2 different methods to convert hexadecimal number into octal number. So in first method, what we need to do, we need to take each hexadecimal digit, we need to convert them into 4-bit binary equivalent based on the table which is already discussed, right? So next step, we need to group them into 3-bit binary values from the LSB. Here for example, we have 19C3. So each hexadecimal digit will be converted with 4-bit binary representation. From the 4-bit binary representation, we need to group them into 3 bits from the LSB. Then each 3-bit will be represented in the form of octal number. So here the result you have to write from most significant bit. So the result is 14703. In case of second method, so first we need to convert the hexadecimal number into decimal number. From the decimal number we can convert them into octal number. So here for example we have C1 base 16. So C is nothing but your hexadecimal number which is multiplied with this positional value 16 to the power 1, and 1 is in the positional value 16 power 0. So we need to multiply with its positional value, and sum of this going to give the decimal form. From this decimal value again we need to do the repetitive division method to get our result. How to convert hexadecimal fraction to octal? So first step, for each given hexadecimal number digit, write the equivalent binary number. If any of the binary equivalent are less than 4 digits, then we need to add 0 to the left side. Combine and make the groups of binary digits from right to left, each containing 3 digits. Add zeros to the left if there are less than 3 digits in the last group. Find the octal equivalent of each binary group. For example, here we have 1948.B6. Each hexadecimal number will be represented with the 4-bit binary equivalent. After combining all the binary equivalent value from the most significant bit, again we need to group them with the 3-bit representation from the LSB, and each 3-bit value will be represented in the form of octal number. So the result going to be 14510.554 with the base of 8. So next is hexadecimal to decimal. When you are converting hexadecimal to decimal, individual hexadecimal digit will be multiplied with its positional value, and sum of all the multipliers going to give the respective decimal result. For example, here we have 7DE. 7 is multiplied with this positional value 16 to the power 2, and 13 is nothing but D. So D is multiplied with 16 to the power of 1, and here 14 is nothing but E. So E is multiplied with 16 to the power of 0. So the sum of all the multiplications will give you the 2014 as the decimal result. And then hexadecimal fraction to decimal. So here also the same procedure what we have discussed in the last slide. So each hexadecimal number will be multiplied with its positional value. For example, here you have 1. The 1 is multiplied with this positional value of 16 to the power 1, and F is nothing but hexadecimal number 15. So 15 is multiplied with 16 to the power of 0, and then similar way we are going to multiply the 0 with 16 to the power of minus 1, and then 1 is multiplied with 16 to the power of minus 2, and B is nothing but number 11, so which will be multiplied with the 16 to the power of minus 3. So sum of all the terms which give you the decimal number. So the converting from any base to any other base. So correspondence of binary and octal number systems. So for example, here we have binary digit 100 which will be represented as 4 in octal, and decimal also it is represented as 4. For conversion from base 2 to base 8, we can use the group of 3 bits and vice versa. So similar way, the correspondence of binary, octal and hexadecimal number systems. For conversion from base 2 to base 16, we use group of 4 bits and vice versa. Representing unsigned integers in binary. So an unsigned integers can be either a positive number or 0, but never a negative number. So in a single decimal digit, it may be starting from 0 to 9, and in case of 2 decimal digit number, it will be starting from 0 to 99. The maximum it can carry is 99. In 3 decimal digit, the minimum value is 0 and the maximum value going to be 999. An unsigned integer containing n bits can have a value between 0 and 2 to the power n minus 1, that is out of 2 to the power n different values. So ranges of unsigned integers represented through n bits. So here the n can be either 8, 16, 32 or 64. So based upon that, the maximum value will be varied. Binary addition. So it's very easier when compared to your normal decimal addition. We need to remember only the tricks or the rules. Okay, so here we have 5 different cases. For example, if you are adding any two zeros, you will get the sum as 0 and the carry going to be 0. And in case 2, when you are adding 0 and 1, you will get sum as 1 and carry going to be 0. In case 3, 1 and 0, you will get the sum as 1 and carry going to be 0. And case 4, if you are adding 2 ones, you will get the sum as 0 and carry going to be 1. In case 5, if you are adding 3 ones, you will get the sum value as 1. At the same time, you will get the carry value as 1. Here we go with an example. So first we have the two binary values like 0 110 and 0 111. So in second step, we are going to add the least significant bit. So whenever you are adding binary addition, you have to go from the least significant bit. So adding 0 and 1, you will get the sum as 1, the carry going to be 0. And third step, you are going to add the second LSB. So here we have 1 and 1. If you are adding these 1 and 1, you will get the sum as 0 and carry going to be 1. And third LSB, you will get 111, right? So when you are adding 111, you will get sum as 1 and carry going to be 1. The final result going to be 1101. So here are the question to practice. Okay, so convert the following octal number to binary and convert the following octal to hexadecimal, converting octal number to decimal and hexadecimal to binary and hexadecimal to octal and decimal. So here add the binary numbers. I have given the numbers, just add it and practice yourself. And in part 3, we will discuss about character and string representation. Thank you students for watching this video.